Algebra students. Today we are going to be solving for x or a or y or whatever variable, but we're going to have square roots, cubic roots, things like that involved. We haven't done that very much before. Okay, so we're going to solve for x when we have radicals. Suppose you have the square root of 3n plus 1 minus 7. Now, the very first thing is that I want to isolate n, right? So I kind of want to get this other stuff on the other side. So I'm just going to add 7 as a first step so that I get the radical by itself. Always get the radical by itself. Now, remember that 3 squared, if I take the square root, that's just 3. And similarly, if I square a square root, then it just stays the same. So really the opposite of taking the square root is to square, so I'm going to square both sides to solve. And then I just do some quick algebra, which you can do slowly if you want, and I get n is equal to 16. But the key here is to square both sides so that I can undo that square root. Now I'm just going to check to make sure that this worked. I do the square root of 3 times 16 plus 1 minus 7 equals 0, and then that's 48 plus 1 on the inside, then that becomes 49. And the square root of 49 is 7. So 7 minus 7 is indeed 0, so that checks out. Let's do another example. This time we're going to have a cubic root. Now, the opposite of a cubic root is not going to be to square, right? Because the cubic root is like what 3 things multiply together. So instead of squaring, I'm going to cube both sides to undo that cubic root. And then I have 2w minus 5 equals 27. I add 5 to both sides. I divide by 2. And I again get w equals 16. There's a whole lot of 16s around here. Now I'm going to check. Okay, so I plug in 16 and see if it works. Does the cubic root of this stuff equal 3? Well, that's going to be 32 minus 5. And then it's going to be 27. And that is true. The cubic root of 27 is indeed 3. So it checks out. Our solution checks out. All right, let's get a little bit more tricky. Suppose we actually have an a term and we also have a square root of a plus 7 term. Okay, we have both. So your first step is going to get the square root by itself. So I'm going to move the 5 to be over with a. The second step that you're going to do is you're going to square both sides again. Now you just have to be careful that you're not going to do a squared minus 5 squared, right? That is bad. I am going to expand rather than distributing the square, okay, because these are added terms. So I'm going to write it as a minus 5, a minus 5. I recommend that you always write it this way. So I'm squaring both sides so that it just becomes a plus 7 on the left. And then I expand a minus 5 squared into a squared minus 10a plus 25. And then I subtract the a and the 7, and I get a squared minus 11a plus 18. And that factors into a minus 9, a minus 2. So my solutions for a are 9 and 2. Those are the things that make that 0. Okay, but I need to check both of these. So first I plug in 9. I see if it's equal to that, right? I'm plugging 9 everywhere where a is. And when I check it out, it works, okay? But now I'm going to plug in 2 and see what happens. Okay, so is 5 plus square root 2 plus 7 equal to 2? Well, that's 5 plus square root 9. 5 plus 3. 5 plus 3 is 8, not 2. So that is actually not true. And 2 is an extraneous solution, so I actually remove it. So that's why you have to check, because often you're going to get an extraneous solution. Okay, so always check when you have square roots. They do funny stuff. Okay, these almost look exactly the same, right? Except there's an x inside the square root there and a 3 inside the other one. So the one with the x inside the square root is not a linear thing, right? But remember that the square root of 3 is just an irrational number, but it's still just a number. And I have a singular x term, so therefore this is just linear. So it's pretty easy to solve for x. I can just divide by the square root of 3. Okay, but then this is not simplified, so I'm going to multiply by the square root of 3 over the square root of 3. I end up getting 12 root 3 over 3, which is the same thing as 4 root 3. All right, let's go ahead and do the one with the x inside the square root. So first thing, I'm going to get rid of that 3 by dividing. Always do whatever is easiest first, okay? And then I just square both sides to solve for 16. So that is that. So they almost look the same, but they were quite different. Next example. Now I'm going to have a even more complicated little situation here. I have the square root of x minus 7, and then I'm adding the square root of x. So I have 2 square roots, right? How do I solve this? Well, first of all, your strategy is to get the more complicated square root by itself. So get the square root of x minus 7 by itself first, and then get all the other stuff on the other side. And then we're going to square both sides just like we normally do. And remember that you have to expand 7 minus square root x squared, rather than just writing it as 7 squared minus square root x squared. Don't do that, ever. Okay, moving on. So we finished expanding, and I realize I have an x on both sides. I'm going to subtract 49 from both sides, and I'm going to combine the negative 7 square root x's into negative 14 square root x. I'm going to divide both sides by negative 14, and I end up with a square root of x is equal to 4. Okay, so then we just need to square both sides of the equation again to get that x is equal to 16. So then I need to just check it. So I plug in 16 in for x there and in for x there. 16 minus 7 is 9. The square root of 16 is 4. The square root of 9 is 3. So 3 plus 4 is indeed 7. So that checks out. Okay, so just note that we're going to have to square twice. When there's a situation like this where I have two different kinds of square roots, I'll have to square twice. I squared first with the x minus 7 and then secondly with the x equals 4. Anyway, did you notice how many problems equaled 16 at the end? That will not be true for your homework, but go ahead and do your homework and you'll get other things other than 16. Enjoy your day.